Electricity is the cleanest form of energy at the point of consumption. However, production of electricity using coal leads to environmental degradation. About 73% of India's total installed power generation capacity is thermal, of which coal-based generation is nearly 90%. Fly ash is the residue of coal combustion process. At present, 90 million tons of fly ash is being generated annually in India, and about 75,000 acres of land is occupied by ash ponds. Appreciating the overall concern for environmental problems being created by fly ash, the Department of Science and Technology, Government of India, initiated the Project Fly Ash Mission in 1994.
India depends rather heavily on the use of coal for satisfying its energy requirements. And one of the side effects of this is the production of large volumes of fly ash, which need to be handled, stored or disposed of. And we produce close to 100 million tons of fly ash every year, which has to be handled very effectively. The main mandate of the mission was to build confidence among the public in the utilization of fly ash for various activities, and that is that in the last 5 years we have been able to raise the level from 3% to almost 13% today, and we intend to further take it up. That is the mandate of the mission. What we have concentrated on is the utilization of fly ash in road embankments, mine fills, in dams, dam structures, building materials, and also in enriching the soil in wasteland development. These are the various areas in which you have been able to promote the use of fly ash.
Most successful impact has been the large-scale usage of fly ash in road sector. The geotechnical characteristics of fly ash which control its use as an embankment construction material are grain size distribution, compaction characteristics, shear strength, consolidation characteristics, and permeability. Fly ash generally has grain size similar to silt. Various advantages of using fly ash for construction of embankments are: lightweight, can be used in weak subgrades, chemical and engineering characteristics are suitable, faster rate of consolidation and settlements are also less, can be compacted over a wide range of moisture content. Low compressibility and ease of compaction, greater stability of slopes due to higher angle of internal friction, can be compacted using either vibratory or static rollers, less variations in density with changes in moisture content. No large lumps to be broken, easy to spread, can be used under monsoon conditions, less interruptions due to rains. Pozzolanic hardening imparts additional strength, conserves good earth, protects environment.
Central Road Research Institute has been engaged in R&D work in the field of roads and road transportation since more than 50 years now. One of the major areas in which we have considerable experience is in the utilization of industrial wastes like fly ash. We have constructed large number of test sections, and those have been monitored in collaboration with state PWDs. Recognizing this fact, CRRI was assigned to organize the task force on roads and embankments by the Fly Ash mission of Department of Science and Technology, Government of India. And under this mission activity, we have undertaken several demonstration projects. One of the pioneering work that we have done was to use the soil reinforcement technique for the embankment for the Okhla flyover. The another such utilization of fly ash is for the approach embankment of second Nijamuddin Bridge, which have been widely recognized. One point should be understood that there is no possibility of any adverse environmental impact due to the fact that fly ash remains buried or confined when we use in the construction of roads and embankments. Another important fact must be understood that the conventional construction machineries can be used in the construction based on fly ash. And there are no difficulties faced according to our experiences with demonstration projects.
Delhi PWD, in association with CRRI and Fly Ash Mission, constructed the reinforced fly ash approach embankment on one side of the slip roads adjoining National Highway No. 2 near Okhla. The length of the approach embankment is 59 meters and height varied from 7.3 to 5.3 meter. About 2200 cubic meters of fly ash was used in this project. The foundation of approach embankment was built on a reinforced bottom ash layer. Bottom ash was laid for a depth of 0.55 meter in 2 layers. Rolling was done using 8-ton static roller followed by a vibratory roller until each layer was compacted to at least 95% of Proctor density. Bi-oriented geogrid was spread over compacted bottom ash layer. Before spreading the geogrid, bottom ash was properly dressed to minimize undulations. The geogrid was stretched to remove waviness while spreading. Nailing with 0.4 to 0.5 meter long mild steel rods of 1 centimeter diameter was done to keep the geogrid stretched. The facing panels for the reinforced fly ash embankment were made of 15 centimeter thick precast RCC panels of M20 concrete. Breadth of the panel was 0.98 meter and height varied from 2 to 2.8 meter. The size of the panels was decided considering the variations in height of the wall, ease of handling, and at least 2 geogrid layers were to be embedded in each unit. Pressed steel from work was used with bolted joints at corners. Reinforcement consisted of 1 centimeter diameter bars placed 2 centimeters center to center. After concreting the facial panels, the top surface was given a trowel finish. Foundation block for facing panel was constructed over the bottom ash layer. M20 grade concrete has been used for foundation block. Joint filling compound comprising of bitumen, sand and a small quantity of cement were heated and poured in the foundation block. The facing panels were lifted by a crane and placed over the foundation block from end to end. The first and the last facing panel had one edge flat and were placed 5 cm from the either ends. The facing panels were lifted from the casting yards about 30 meter away, brought to the site, lowered in the foundation block and moved sideways so that the edges fits into the adjoining member, and then it was resetted on the bottom of the block. The geogrid rolls were connected to the anchored geogrid strips embedded in the facing panels. Geogrids were stretched by pulling with hooks and anchored to compacted fill with 1 centimeter diameter rods. Fly ash was spread over it. The compacted thickness of ash layers were 20 centimeter. Moisture content was kept at or slightly less than optimum moisture content. Adequate moisture was added to fly ash whenever necessary. Each layer of fly ash was compacted to required density. Along the facing panels, filter media was provided. The flyover was opened to traffic in January 1996 and to date its performance has been excellent. The project proved that fly ash is a better fill material and can be used to replace good earth. More importantly, it paved the way for taking up similar embankment projects using fly ash. The result was use of fly ash for approach embankment in Hanuman Setu project and the eastern approach embankment for second Nizamuddin bridge, in which fly ash was used on a massive scale for the first time.
The number of embankment roads have been constructed using fly ash like Visvesvaraya Setu, Hanuman Setu, approach embankment to the Nizamuddin Bridge, etc. Till date, no deterioration has been observed. About 15 to 25% saving can be achieved depending on the lead. Guidelines for the use of fly ash in road and embankments have been drafted for Indian Road Congress by the CRRI.
The second Nizamuddin Bridge across River Yamuna on National Highway number 24 stands out as a novel example of the large-scale utilization of fly ash in highway projects. Fly ash from nearby Indraprastha power station was utilized for the construction of the eastern approach embankment of the bridge. Delhi PWD, in association with Fly Ash Mission, took up the construction work of approach embankments for the second Nizamuddin Bridge and decided to use fly ash. Central Road Research Institute was entrusted the job of designing the embankment, carrying out material testing, and providing assistance for quality control supervision during construction. The Noida side of the bridge approach, which is about 1.9 km long and approximately 6 to 9 meter high, has been constructed using fly ash. The project has been unique of its kind since for the first time in the country, fly ash embankment has been constructed in a flood zone and no reinforcement has been used except soil cover and stone pitching. Design has been carried out using computer software, adopting slip circle method, and it was checked for stability against earthquake forces.
We had two early experiences on two flyovers, and that's how actually we got the confidence. Not only with fly ash but also with the fly ash mission. The working with fly ash is in fact easier than working with earth. For example, in this very project, whenever there was a rain, working with earth was very difficult for next few days. While in the case of fly ash, we could start reworking after a gap of maybe a few hours. The supply of fly ash has been quite consistent from the Business Board. The CRRI has been very consistent in their designs and their quality control, and the fly ash mission has been continuously monitoring that required quantity of fly ash is available to us in time. The quality of fly ash, although there were some variations, but there were nothing abnormal. I think variations in soil are also no less, with which we are used to working. Likewise, the experience of workers, there were absolutely no apprehensions with the workers. They were quite comfortable working with the fly ash, and they never had any complaints. Because mainly because, of course, that it was ash pond, there was no flying particles most of the time.
The embankment has been constructed using fly ash as core material with soil cover. To facilitate compaction and to provide additional stability, fly ash and soil have been laid in alternate layers in the embankment. 2 meter thick fly ash layer was overlaid with 0.4 meter thick soil layer. The post-construction performance of the embankment has been monitored through instrumentation. Settlement gauges have been installed to monitor total settlement at different levels. Pressure cells for recording the total pressure and piezometers for monitoring pore water pressure have been installed at different levels. The monitoring has shown very good performance. construction of the embankment was completed in a record time period of about 8 months, some problems were encountered during execution. Unseasonal and heavy rains during the initial phase led to the spreading of compacted ash. This was corrected using dozers and the ash was recompacted.
This problem is very common even in soils and is resolved similarly.
One stretch of the embankment has been constructed through an existing deep pond. In this stretch, initially gravel was spread to obtain a dry foundation bed about 1 meter above the existing water level. An ash embankment has been constructed over this bed. To protect the embankment, the foundation bed of gravel has been laid for an additional width of 5 meter at the toe of embankment. Total consumption of fly ash is about 1.5 lakh tons.
On right of my, you can see that still there is a water logging, and we can imagine the depth of about 8 meters which are filled up with fly ash. This experiment or experience of fly ash in Nizamuddin Road embankment has expelled all the fears of civil engineers that fly ash cannot be used in the flood zone areas for embankments, and in flooded conditions it will collapse. This embankment is now operational for last 3 monsoons and has not shown any problems of any type. Fly ash, by its use in roads and embankments, saves the environment in more than 3 ways. Number 1, we use the fly ash which otherwise would occupy the land. Second, if we do not use the fly ash, we would borrow the soil from some other area, and by digging out or excavation, low-lying areas would be created. Third, by use of fly ash, we are helping thermal power stations to clear up their ash ponds, which otherwise would keep on asking more and more land. Thus, use of fly ash is environment friendly. It also becomes economical. In this particular embankment, Nizamuddin embankment, PWD has saved more than ₹1 crore by not transporting the soil from more than 40 kilometers distance. Similarly, Delhi Vidyut Board has saved about 30 lakhs of rupees by way of less cost in disposal of fly ash. Thus, we can conclude that fly ash is a safe, technically, scientifically, as well as it's economical for use in roads and embankments, and we should adopt this technology at a larger scale.
CRRI has been awarded for excellence in consultancy services for the second Nizamuddin Bridge project, and the prestigious CSIR Technology Prize for 1999 has been awarded for the R&D work and demonstration for utilization of waste materials, especially fly ash for roads and embankment construction.
The basic message I would like to bring is the roads is one of the major infrastructure in the country, which is very important for all of us. Now, if we can make use of fly ash in the roads and embankment, this will lead to not only a much larger amount of roads be built without spoiling or wasting the topsoil, because every filler material requires topsoil, and the consequent degradation of the land area, which is scarce, and the use of fly ash will eliminate this, and we will also be value adding to this by utilizing the fly ash in the place of topsoil. And I would like all the public organizations, the PWDs and state governments to replicate this in a much larger extent.